Hi, Chandaka.
Hello, Bobby. So here we are again.
Yeah. What is this? You are some primitive device. I see a piston, spring, and a piston winder.
It's a primitive device,
Hmm.
but it's a smart device.
Ah.
So as you said, we can see some fluid here,
Yeah,
piston, and you can see a spring here.
correct. And the pointer is hinged on
Exactly.
that.
Is connected to a scale. So just by looking at it, right, you can say it's measuring something, right? Because there's a scale.
Yeah, there is a scale. There is a,
So there must be.
yeah. So if the piston goes up, the pointer will come down, and vice versa.
But then why would the piston go up?
Somebody has to push.
Somebody or something has to push, right?
Correct.
So here below you can see fluid.
Yeah.
And this fluid,
Ah.
let's say there's an inlet to this vessel,
Okay.
right? Sorry. And there's some fluid coming in from somewhere,
Oh, okay.
okay? And that fluid goes in, this level increases, and then somehow, let's say the fluid can also go out.
Oh, so if this is connected to a pipeline or something,
For example,
and if the pressure inside increases, then there will be more fluid
Exactly.
into this chamber, will push up,
exactly.
will show the reading.
Exactly. So when the fluid pushes the piston, that provides an indication
Mm-hmm.
of the pressure, for example, as you said, in a pipeline.
Yeah.
Right? So then this movement of the piston, now the movement is connected to a spring.
Yeah.
Okay.
Yeah, if there is no spring, always, I mean, even with small pressure, it will just go and hit on that.
In the top.
Yeah.
Right? And that's not what we want. So the spring obviously controls the amount of movement, right? The
Or,
piston-
yeah, it is working against the
working-
pressure.
There's some friction there, right? Working against it. And then that is translated, the movement of the piston is translated to a scale through a pivot. Okay. So, what do you need to
For this to work,
use something like this to measure pressure? Because you said, let's say that's a good example, pressure of a pipeline.
yeah, I
Now you
can
have-
just connect to a pipeline.
Nothing.
And,
Nothing.
just displays. Yeah. I don't have to power this.
It's a pretty good device, right?
Oh, that's true.
Isn't it? Don't you think? I mean, you were making fun of this device before.
Yeah.
So in the sensors world, we call this a passive sensor. Passive
It
sensor?
doesn't require any external energy.
Exactly. It does not require any external energy, and it can still measure that measurement we talked about, the physical variable. But that can only be used if there's some kind of naturally occurring
Correct.
physical variable, right?
Yeah.
So it could also be, I mean, not in this case, but if you think about a temperature sensor,
Yeah.
that could also be a passive device, depending on the principle of measurement,
Mhm.
right? As long as you're not applying a voltage or current to that device for it to work,
Mhm.
right?
For the sensing element to,
For the sensing element, exactly. We are specifically talking about the sensing element. And here it's a very simple device, but still you're not, as you said, you don't need any energy,
external,
external energy.
because it may be taking some energy from that fluid for the piston to move up.
Of course.
Yeah.
Of course. Yeah. Right. But then that's
That is stored in the spring
uh-huh.
and it releases when it.
Exactly.
So,
And also that energy is coming from the pressure of the pipe.
correct. Yeah.
Okay. So they are
So its final position or the equilibrium position is the force provided by the spring and the force provided by the fluid. They are equal and opposite.
Yes.
There it stays.
yes.
Okay. Okay.
That is let's say the reference or the 0 point.
Mm-hmm.
Okay. So passive sensors. What is
So
this?
you mean 0 point at the time there will be no force from the fluid.
Yeah. So
The spring will be fully released.
yes, but
That will be the 0.
that will be 0.
As the pressure increases, it goes up.
Yes.
Yeah.
Yes. But even at some stage, if the pressure inside the pipe is 0, right, there could still be some fluid inside. Am I correct?
Yeah, fluid can be there, right? Yeah.
This doesn't have to touch the bottom,
Yeah.
right? There could still be some fluid here.
Correct.
Okay. But the main point is here, as you said, then it's balance. Got the forces, springs, and bells. Yeah, we call it the
The force provided by both of them are equal and opposite. That's the equilibrium,
equilibrium. And then you can go up or down according to that.
depending on the amount that you're.
Right. So again, up or down, this goes up or down. The scale. The pointer here.
Got it.
Right. Okay. Now, what is this? This looks like a very primitive device.
Oh.
What does this look like?
Oh, this is very high end. What is
Right.
this?
You have a car here.
Autonomous car or something?
Could be. Could be. Why do you say autonomous? I mean, looking at the picture, what made you think this is an autonomous car or self-driving vehicle?
Yeah, looks like the car has some sensors and is trying to map this environment and the road.
Yep, absolutely. Right? So that's exactly what's happening here. This car somehow is mapping its environment, right? Which is why you see, different like
Yeah.
cars, other vehicles, trees, buildings, right? But it's also using sensing technology here.
What do they do? I mean, what's the kind of sensor?
Have you heard of LiDAR?
Oh, okay. I've heard about radar, but it's not radar.
It's not radar.
It's
Called
light. Okay. LI.
Yes.
Okay. So I heard about this LiDAR.
Yeah.
It's a little bit complicated to understand, probably.
Actually, I don't think it's difficult to
What's the
understand.
basic idea?
So the basic idea is that, light detection and ranging. Right? So let's say this car, let's say has some device,
Okay.
okay, that has a source and
It sends out something.
it sends out light waves.
Okay.
Okay, all around actually.
Okay.
You can see here, right? These things here, and the light wave reflects back. Now there's also the time of flight. That's between the time between transmission and receiving.
Okay.
And based on that, it can detect not only the distance, right, which is from the objects, also can image what's around it.
Okay.
Based on that, it can create a real-time map.
So it may be an array of sensors
Exactly.
doing this. Okay.
Multiple sensors that can perform that.
Cool.
So, what?
Maybe we'll see the details later sometime in this course.
Yes. I think it's a technology that used quite a lot, really. So driving cars is or autonomous vehicles, they use LiDAR for sure. So Bobby, here now compared to this one, now we said here what did we say? We said passive sensors
Yeah,
do not
for
require
the
extra power.
pressure sensor there, we didn't use any external power or no source.
Because we don't need it.
But here you are actively sending something
Yes.
out and then.
Exactly. So here you have a source.
Mhm.
You have to send something out, right?
Got it.
And then something reflects back into a receiver
That you measure.
that you measure. So you need some sort of external source or energy
Correct.
to activate this sensor. Okay.
So if that is passive, then this could be an active example for an active sensing.
Exactly. So this
Or
sensor
sensor.
is called an active sensor. So active sensors, they emit their own energy, right? Travels from the instrument or the device or the sensor device or whatever you want to call it, and to the target to be investigated, right? And based on that, you make certain measurements.
Yes.
Right? So when you're talking about sensors, these are the two main types of sensors: passive sensors and active sensors. Okay. What is this, Bobby?
Oh, I think Christmas is coming. Here are a lot of lighting arrangements.
We have a very vivid imagination, Bobby.
What is this?
So what do you see here with the lights? The brightness of the lights.
And now I am able to make out. You are making a plot of the brightness of the lights present there. Is it?
And that, yes.
Okay.
But this, that means that this plot is changing.
Mm-hmm.
And changing according to the brightness.
Okay.
Now, let's say your sensor output.
Hmm.
Let's say this is your sensor output. Sorry. My handwriting is not very good. Let me do this again. Say you have something like this. And let's say this is timed. And then let's say this is your sensor output.
Okay.
Your sensor output is constantly changing.
So this means I have a light source where I kind of arbitrarily change the brightness with respect to time.
Yes. Or
Then you are sensing that.
yes. Let's say, for example, exactly. Let's say you have a sensing device that is measuring the brightness of the of the bulbs. Correct, right?
Correct.
And that is changing over time, and your sensor output is giving something like this. Output. Some output.
Yeah.
Okay. What do you have here?
Oh, here I see only maybe two states,
Two states. What are two states?
either off or on.
Either off or on. Right? So two discrete states. You don't have this smooth transition
Yeah.
to the highest brightness and down again.
Yeah.
So if you look at this output,
Okay. It could be something like
it
this.
would be something like this. That is either on.
So the output is somewhat digital.
Yes. Now remember we talked about analog to digital converters,
Correct.
right? So what if I ask you, can you change a signal like this into this?
Maybe I can put a threshold and say anything above I consider as 1, below that I consider as 0.
0. Yes. So in this case, sensors that provide or give an output like this that is constantly changing
Yeah.
because
It's changing continuously.
it's changing continuously.
While here I can see it 1, 0.
Yes.
With
Yes. We call this
analog output sensors or
or analog output sensors or analog sensors, which means these ones are called
digital.
digital sensors.
So it's based on the nature of the output.
Nature of the output, right? Because most of the measurements that we encounter are kind of analog. Most of them. I mean, I'm sure there are digital. I'm not sure. I cannot think of an example, but generally, most of the environment measurements are analog, right? Constantly changing over time.
Yeah.
So here we talked about passive and active sensors. Sensors can also be analog or can provide an analog or digital output. Okay. Now here, if you look at the digital sensors, it's not just on or off. There can be more information embedded in this digital.
Okay.
For example, if you look at the width, it's different, isn't it? Right? So that could provide some information on the output.
So I can have a duty ratio.
DT, right? How long it's on, how long it's off, right? Plus, another example would be the
Maybe the frequency itself.
frequency itself, and also the information that's sent over a period of time. So what I'm trying to say is, if you take this one and if you take this one, you see
They look very different.
they look very different. So that could also mean that the information is different. That sense is right. So it's not yes, it is on and off, but there are also ways
You mean information can be embedded in this?
embedded in the actual digital signals. If you look at a trend over time,
Correct. Got it.
right? So at the end of the day, so now we count passive and active, analog and digital, right? Two main types of sensors.
Yeah.
Okay. Right. So this is just an example, right?
Tooth wheel.
Some
What are you going to do with this?
I just want to show you,
Right.
how an analog sensor and a digital sensor would perform in a situation like this.
Okay.
And what are some of the limitations, let's say, of a digital sensor? Now we know
But what is a sensor here? I
This
see
could,
the wheel.
yes. So here,
Then I see a torch kind of thing. What is that?
yes. So this, in this particular case, it's called a Hall sensor,
Hall
depending
sensor.
on the Hall effect, which is a magnetic sensor.
Okay.
Okay. I mean, this is one of the sensors that we'll cover
Oh,
in,
you will
a,
see
in
this
a later
later.
class. Yeah. Study depth.
So what it senses?
It senses the magnetic field.
Okay.
Right? So it's a magnetic field sensor.
Oh.
Now, if you look at this
But the wheel is not magnetized, no?
wheel, is not magnetized.
It's just
so it's a very nice, elegant way of measuring the speed, for example, of this 2-gear system.
Okay.
So, what do you see here, though?
Oh, I see some north-south.
North-south means what?
Maybe a magnet?
Wheel line, right?
It's a permanent magnet.
Yes.
Oh.
Which means there is, you can see some
Magnetic field.
magnetic field going from north to south, right?
Okay.
Okay. And that's connected to the sensor. Now, you said, yeah, go on.
And this toothed wheel is made of some magnetic material?
Some maybe ferromagnetic material, or just some magnetic material that interacts with this magnetic field.
So that modifies the magnetic field.
Yes. So when it's turning, for example, when the tooth is close, it interacts with this magnetic field.
Okay.
Okay, and changes the magnetic.
So you measure that change in magnetic field using Hall effect sensor.
Yes.
Okay, right?
But what happens when the tooth moves this way a little bit, and you're ended up in a situation like this? What happens then?
So it's not modifying that magnetic field of the permanent
Yes.
magnet.
So if this, for example, if I say that the tooth gear is somehow interacting with the magnetic field, let's say the flux or the magnetic field, in this case, you can say if it's interacting, it's increasing.
Yeah, it may be increasing or decreasing. I'm not sure.
Yeah. Right? And in this case,
Yeah.
if this is increasing, then they should decrease.
Be the other way.
Be the other way, right? So, if you look at the sensor output, right, we have a digital and a analog output. Okay? Now, which means the whole sensors can be analog or digital, right, depending on how you design and, kind of fabricate it. So, if you look at those two graphs,
Suppose if this was a smooth wheel, smooth periphery,
totally smooth. So you mean just like something like this?
will I get something?
You get something, but there will be no change.
No change.
Right?
Unless otherwise it's a oval shape or something.
Yes, exactly. Or, I mean, you could, or for example, if you have very small teeth, for example, right, then this change will also be very small.
Very small. Also, these are the factors that you may take into account while forming this toothed wheel.
Yes. So, for example, if I tell you, I have this tooth wheel, it's rotating. I want to know the speed. A Hall sensor would be a good sensor to use in this case. Wouldn't you think? So,
Yeah, because I also see you are not touching it. You are able to measure without touching.
exactly. So, it's non-contact.
It's a non-contact way. of measuring.
Non-contact, non-invasive way of measuring the speed of something. And that's important. Why is it important in something like this? In a wheel like this? What would happen if there's constant friction over time?
So if it is not non-contact.
Not.
Yeah. If it's a contact-based one, then you may slow down.
Yeah, you may slow down. You may slow it down.
Yeah.
Correct.
Then the purpose of measurement itself is lost.
Right.
Because that is something fundamental. No?
Yes.
You are trying to measure something, and in that process, if you modify the measurement, then your job is gone.
Yes. You'll be fine.
Yeah.
Okay, so now if you look at the two outputs, right?
Yeah.
What would you say? Like if you have a analog output, you have a very smooth transition.
Correct.
But if you have digital output, you have either on or off. So maybe, just maybe, if you have an analog sensor, you'll be able to see the movement of the tooth, right? From one tooth to the other in a smoother way.
How is that movement?
How is that movement?
Even within one tooth, width of one tooth.
Yes. So if you're going from, for example, from this tooth to this tooth,
Yeah.
right? This change,
So you get that change like this red.
you get a smoother change in that output. However, if you have a digital sensor, right, you might only see, because as you said, let's see, you have some threshold,
Yeah.
right? Then you'll see either yes or no. So here you have your tooth
Got it.
and no tooth, right? So if you want to measure something and if you're interested in very smooth transitions, then you're better off having an analog output.
So if you just want to measure the speed or something, in this case, the digital output may be fine.
Exactly.
But on the other hand, how many degrees it has rotated if you want to find? Then you may need the red one.
And we'll see as we go along. I mean, when we talk about different sensors, we'll see that it's very important to consider the application, right? And the type of sensor you use. I think that's one of the most important criteria really for choosing a sensor. Okay, so
this Hall effect is a passive or active one. We will leave that to the student. Or when we teach that Hall effect, we will discuss. Yeah.
I have,
Because we have not discussed what is Hall effect.
yeah, that's
it's not correct to.
Yeah, this is true. Yeah.
Yeah.
I don't want to be confused.
Correct.